So all of our meters have Modbus mapping, and our meter manuals, which can be found on our website, have those Modbus registers. So if you go to our website, electroind.com, if you are familiar with our products, you may notice the website has changed quite a bit, but we still have all of the same information on the website. So if you click on the products link at the top, all of our meters will show up. We have our Nexus series meters, socket style meters, and our Shark series meters down here. Today, I'm going to be connecting to a Shark 200 over Modbus, but whichever meter you're looking at, you can view the Modbus mapping. So if you click on your meter, under Tech Documents, you have the user manual. I've already opened that up here, but this is where you'll find the Modbus mapping for the Shark meters, is in the Tech Documents meter user manual. So here's the manual. Through the table of contents, you can find all the information about the meter. Appendix B here is the Modbus mapping for the meter. So if I click on this, this goes over the specific registers, data formats, meter log information. We'll get right into the actual polling of the registers. So page MM1 is where the actual Modbus mapping starts. This fixed data section here is the identification block. This has specific information about the meter. So your meter name, your serial number, what type of meter it is. Down here, MM2 is where we actually start the meter readings. So if you're familiar with the Communicator EXT software, you can connect to a meter. In my case, I'm connecting to a meter locally here. If you are connecting to a Shark 100 meter, that default IP address is 10.0.0.1. Our Shark 200, 250, and 270 meters, those have a default IP address of 10.0.0.2. So just as an example, if I open the polling screen, this shows me my line to neutral voltages, line to line, my current. So if I come back to the Shark 200 user manual, you'll notice here that we have a readings block integer values. These are 16-bit integer values. We also have a primary readings block that are in floating point. So if you have a system that cannot handle floating point values, we do offer registers that will show you 16-bit integers. For my case, I'm going to be polling the floating point values. So my starting register is register 1000. Because these are holding registers, this is actually a 41,000 register. I have 3 pieces of Modbus polling software to show you. First one here, using ModScan. You set up a connection by hitting connect. I'm choosing remote Modbus TCP server. You put in the IP address of the meter, the service port, and you click OK. It starts polling the meter. You'll notice I don't have any valid responses because I don't have this piece set up quite yet. So my starting register address was 1000. I'm only going to take, say, 20 registers. The point type for Modbus, you have coil status, input status, holding registers, input registers. These meters, we're going to be polling the holding register. And so right now you can see that I'm getting values, but they don't look anything like what they should. So in setup here, display options, You choose floating point, most significant register first. And now I have values on ModScan that match what my communicator EXT is telling me. So register 41,000 is giving me 122.13, and I have 122.13 over here. And so you can see that volts A to N, B to N, and C to N should be my first three registers. So I can tell that that's already working. The reason why I have a couple different Modbus polling software open is because if we use Modbus poll, I still choose a Modbus TCP IP connection, set up my IP address, and again, we're looking at starting at register 0. So the ID, this is the Modbus address, which is 1 over the IP address. We are reading the holding registers. You can choose to put your address in as either a decimal or a hex value. If I come back to the user manual, we have two options for the Modbus address. These are the hexadecimal register addresses, and these are the decimal register addresses. So you can choose to use decimal or hexadecimal. So my starting address, you'll notice even though it says 0 here, the PLC address is 40,001. That 4 is put in because we're looking at holding registers here. And you'll also see that address 0 starts at 40,001. So if I type in register 1000, say we'll look at a quantity of 20 again, scan it every 1 second. Apply and OK. Again, you'll notice that my numbers look a little bit screwy. On Modbus poll, you can right click and format a point and choose to look at a floating point value. So when I changed it to floating point value in ModScan 32, I started getting my correct voltage values right away. Right now, my number still looks messed up. This is because depending on what kind of SCADA system you're using, you may have a polling system that starts at base 0 or base 1. In ModScan's point, polling starts at base 0. Modbus poll, it starts at base 1. So what we'd want to do here, instead of starting at register 1000, is we will start at register 999. So now that point that I was looking at as a floating point that was giving me very small numbers is now showing correct at 122.18178. And you can do the same for all of these since they're still looking different. Format, floating point, and now I have the correct looking values. So there's not a whole lot to it, but we do have a couple, there are a couple caveats and gotchas that we end up working with here. Because there are some SCADA systems where you would prefer 16-bit values. I'm going to show you this really quickly as well. So on ModScan, I'm just going to look at register 279. And now because it's a 16-bit integer value, I need to change my data type to integer. You'll also notice here that all of my numbers are reading 10,000. So if you come back to the manual and you look at the notes, point number 3, if the reading is 10,000, that means the value is out of range. So the shark meters can be set up to auto scale for power. So if you have low usage, it can be giving you watts and then kilowatts and then megawatts. It can also auto scale the decimal point. So what you can do, if you are seeing these 10,000 values, if you open the meter profile, in display configuration, I can, under general settings, display configuration, I can enable a fixed scale for voltage display. You can look at just whole number voltages. You can look at kilovolt values with decimal points. Since I'm only at 120 volts, I'm just going to show whole numbers without the decimal points. I'll just update this meter really quickly. We might time out before it starts back up again. So I might have to reconnect. Because I am updating the profile, the meter is restarting. So you will lose communication to a meter when you have to make a change to the profile. All right, this update is finished. We did lose the connection, so I'll have to just come back in here, quickly reconnect to the meter. Now that I'm polling register 279 and I set a fixed scale for voltage, now I'm getting my voltage values in. You'll notice that we don't see the decimal points, but the voltage values are coming through just fine. The current values here, looking at the Modbus map, we have amps A, B, and C, which should be next, are still reading 10,000. That's because I only set up a fixed scaling for the voltage, not for the current. So current is still auto scaling. Some of you familiar with the Shark 200, 250, and 270 meters may also be looking at energy values. The reason I say Shark 200, 250, and 270 is our energy registers start at register 1500. The Shark series meters, those start at register 1100. The Shark 50 and 100 meters start at register 1100. And again, you can find all that information in the meter Modbus map. So if I switch over to register 1500, I'll only look at 6 registers here. So you'll notice, even though ModScan is set to integer values, I am still getting numbers here. If I look at the energy screen on Communicator EXT and bring back ModScan, my delivered energy value of 929.2 watt hours, I'm getting 9,292 as a value here. Integer values do not transfer the decimal point. So if you are using decimal points on your meter, you will have to take your SCADA system and do a multiply by 0.1 or divide by 10 or 100 to get your 1 or 2 decimal points to show up on your graphical interface. If you, as the energy registers continue to accumulate, you'll fill up this register 1503 and start coming into register 1502. So when you first install a meter, if you are looking at 16-bit integer values, everything's going to look fine until you get past that point where it's only writing to register 1503. So what you'll want to do on your SCADA system, when you choose your data type, you'll do a long integer. Some SCADA systems call it double. Some do dint. It all depends on the SCADA system that you're using, but there should be some sort of long integer value, 32-bit integer value you can choose. So if I choose long integer most significant first, the number doesn't change, but now as we get past the point where it's only writing into 1503 and starts writing into 1502, we get one long number instead of two different ones that have to be parsed and edited. On our Shark 200, 250, and 270 meters, we also have option cards. And anything that's available on our meters has a Modbus point mapped to it. So if I scroll down here, we have the option card settings. Depending on what option card you're using, is what Modbus register you would pull. If you aren't sure if you have any option cards plugged into the meter, through our communicator software, if you go into Tools, Option Card Information, this will tell you what type of card is plugged in to which card slot on the meter. So in slot 1, we have the network card settings. Card 2, we have a pulse output, digital input card. So this section starts our options for card 2, and these headings is what you'd want to look at for matching up your type of card. So we would come down here, here's the network card, and here's the accumulators. So this is the card that I'm using, the four pulse input accumulators and the 4 KYZ outputs. So if I wanted to see any information from this card, these would be the registers I would pull. The command section, if you decided you wanted to make your own communicator EXT software, we provide all of the Modbus registers for setting up a meter as well. This video is not going to show that setup because that is an involved process, but we do provide every Modbus capability to pull a meter, configure a meter, even retrieve logs from a meter. If we scroll down towards the bottom of this map, we have one more section of readings. So this is the secondary reading section. So I did show you the at the very top of the Modbus map, there are 16-bit integer values, but if you don't set fixed scaling in the meter, those values just return a 10,000 number. This section will actually allow you to view secondary readings without setting fixed scaling. So where this is saying register 40,002 for volts A to N, if I come back in here to ModScan, I would want to type in 40,002. So this 40,000 does not indicate it's a holding register. This is actually part of the Modbus register. So now we're looking at 440,002. And I just have to change that display back to an integer value. And this number that I'm getting here is 3,720. So now if you come back and look at the map, a value of 247 equals 0. a value of 4,095 equals 150 volts or higher. So to figure out what your voltage is, we would use this formula. And because ModScan is just a basic polling system, we don't have the capability of putting formulas or scaling in there. So I'm just going to show you with the calculator what we'd be looking at here. So all you have to do is take 150, multiply that by the register value, which is 3719, minus your 2047, and divide that by 2047. And now we get 122.52. And again, if you come into polling, we see 122.5657. So depending on when you poll it and when you make that calculation, the values might be a little bit different, but we can see that we are getting the correct values. So we do offer those three different options: primary 16-bit values that have to have fixed scaling on the meter. We offer the floating point, which will auto scale with the meter. And we also offer the secondary readings that require a scaling or formula to be inputted, but then you can pull 16-bit values while still having auto scaling on the faceplate of the meter. So that pretty much wraps it up for the Modbus polling on the Shark Series meters. Again, on our website, we have the Modbus manuals for all of our meters, Shark and Nexus. When you just come into the products page, you just choose your meter, download the manual for that meter, and Appendix B for the Shark Series meters holds the Modbus mapping. Any more specific questions, you're free to email support@ElectroIND. You can also email sales@ElectroIND, and your sales manager will get in touch with the proper person. But I hope this video helped explain how to pull the Modbus registers from our meters.